A study I saw recently looked at the cost of a 7 kilowatt system in Australia, in Germany, and in the States. And so for Australia, it was about $4,000 US. I think for Germany, it was about 10,000. But then in America, it was 28,000 US.
That is Gavin Mooney, Australian Energy Transition Advisor. He explains how the same 7 kilowatt system costs only $4,000 in Australia and why the US pays up to $28,000 for the same thing.
In the US, there's a lot of soft costs around things like permitting, can take weeks or months. I understand the sales and marketing costs are pretty high. There's sort of state level rules which add another layer of complexity, and there's all this paperwork that drives up costs. And if you compare that to Australia, we have a really flourishing solar installer market here with a lot of competition. And that competition has really driven a lot of efficiencies in the market.
In this episode, you will learn why rooftop solar in the US is more expensive and the major issues causing this problem, how Australia faces structural reforms to cut off soft costs, make solar more affordable, and unlock rapid battery adoption, and what can other markets copy from Australia's solar success. I'm Peter Pongratz, and this is Soliverse, the future of solar. Many things happened this week. I attended this event in Brussels because it's just down the road, and basically it was a European solar summit or something like that, and it was quite helpful to kind of understand, not just the regulator's perspective, but also the perspectives of the fact that we need to zoom out. And by zooming out, I mean, until like 2024, we were really like more solar, and that's the fastest. Then it kind of transitioned into more solar and BESS, more flexibility. This year it's really going to be BESS. But it was super interesting to hear, for example, industry associations like Metal Construction, the European Metal Association, and they were giving some pretty interesting arguments about what is happening on their markets and why cheap energy is important for them. And they were just saying that, like 50 euros a megawatt, we can keep the lights on. But if the price goes at 90, then we are good as dead, so we need to almost move out of Europe and there won't be any production. So these are the kind of things that you never think about, right?
No, I think that's really interesting because a lot of the energy intensive industries, the price of energy is such a massive input into their overall operating costs and their whole profitability model. And so, like you say, if the energy becomes too expensive, then they just can't really sustain it. I know we have some industries here in Australia, like aluminium smelters, where they might need subsidies from the government to keep them going, or they certainly need to lock in a really competitive energy price. And if they can't do that, then it just doesn't work. But I think the flip side is also true. A country that can generate huge amounts of competitively priced electricity, and something that we're seeing more and more demand for is green energy, then I think the industries will come when that's made available to them.
That's the main thing. And here in Europe it's a bit awkward because we are trying to reduce carbon, but with all the norms, but so far it partially has impacted the industries as well, that we were optimizing, but it led to higher costs of production, right? Industries leaving, and then we are only responsible for, I think, 8% of the global CO2 emissions. So, that gives you like an indication of how much you actually produce, right? And okay, we are a little bit further ahead than for example, Asia in terms of clean production, etc. But you need to find the delicate balance between the two, and that's really, really a difficult spot to be in.
It is. And I think a lot of the people that are not really supporting renewables are supporting a fossil world. They point to Europe and they claim that Europe's pursuit of a green agenda has led to deindustrialization on the continent. And, I'm not sure if that's really the cause, but there's certainly a correlation there, isn't there? And so it's a pretty strong argument.
Yeah, it's a tricky discussion to have, and especially on our realms as well. Everybody is renewable and solar focused, but what I keep hearing from everybody across the globe is if the finances make sense, everything will take care of itself. And this is, I think, the ultimate line that can be applied across the industry, whatever the industry is. And I think this is something that we should really focus on as well. So on that note, maybe we can segue into Australia. So you're, of course, based in Australia. You've been active on the market, and to some extent, Australia is somewhat ahead of the market as well, right, compared to the globe. So why don't we start there?
Yeah, sure. I think Australia is a really interesting country because we have this huge history of coal-fired generation. We're a really big polluter. Our electricity has traditionally been really dirty, and we're also a massive fossil fuel exporter. But at the same time, we're very much on the cutting edge of renewable energy adoption. And I think one of the really key areas where Australia leads the world is in this rooftop solar adoption. And I think for me, there's three main reasons why we have so much rooftop solar here. The first one is, it's just a sunny country. So we not only have a lot of sunny days per year, but the sunshine here is quite intense as well. And then Australia's obviously a big country, but also our cities are quite sprawling. They're sprawling suburban cities with a large proportion of the housing stock being detached dwellings. And so what that means is that a lot of people have got plenty of roof space to be able to accommodate solar panels. And then the third point is that traditionally retail energy rates in Australia have been pretty expensive. And so if you can start generating some of your own electricity, it means, you can save a lot of money. The payback is pretty quick. And so we have not only the physical ability to install solar panels, but we also have the economic incentives. And so the transition here has become, customer-led surprisingly quickly.
That's very interesting to see, because I think I saw a piece of data on LinkedIn the other day that to produce 1 kilowatt hour in Australia can be like 2 to 3 cents. Correct me if I'm wrong. Versus I think the contrary example was US, and that was something like 8 to 10 cents on a residential level. So that's also an interesting gap, right? So you kind of have the perfect conditions, but also the willingness to do that, right?
Yes, I think it's interesting to compare the costs. If we're talking about, say, rooftop solar, a kind of rough rule of thumb we have here is that it's about 1,000 Australian dollars per kilowatt of generation capacity. And a study I saw recently looked at the cost of a 7 kilowatt system in Australia, in Germany, and in the States. And so for Australia, it was about $4,000 US. I think for Germany, it was about 10,000. So, quite a lot more. But then in America, it was 28,000 US. I think it's really interesting to kind of look at what went wrong. What has Australia done so well that it's now so cheap here, so cost effective, and why are the other countries lagging so much?
Yeah, that's an interesting point as well, because you mentioned a couple of items there, right? The components that actually go into producing solar. So you need to have the space, you need to have the kind of willingness of the public at large, to install these installations, because you have a little bit more spread out cities. It's similar to the US, but perhaps there is and was most of these things built on a grid-based solution, right? And if you were a little bit more remote already, then you had an automatic incentive to be self-reliant, right?
You did, exactly. I think with Europe, one of the things holding it back could well be, like you say, a lack of roof space, which is why, is it balcon craft, or the balcony solar is becoming quite popular. But in the US, as far as I know, there's a lot of soft costs around things like permitting. Can take weeks or months. I understand the sales and marketing costs are pretty high. There's sort of state level rules which add another layer of complexity, and there's all this paperwork that drives up costs. And if you compare that to Australia, we have a really flourishing solar installer market here with a lot of competition. And that competition has really driven a lot of efficiencies in the market. So, it's fast, simple permitting, relatively quick interconnection, low customer acquisition costs. If I give an example, I could call up on a Monday, call up a solar installer, and I'd have panels on my roof by the end of the week. It's that quick.
We were talking about, what's cool is the balcony installation, right? And red tape. So I've spoken to many folks in the US, and everybody is saying the same thing, that the first and most important step for you to take as a developer is really to get to know the community and try to educate the community that, if there is a solar farm or a solar panel on your roof, you're not going to grow a third hand or something like that. And they really tend to emphasize this, that we really invest a lot of time into speaking to the local city council, whoever the decision makers are, because it's crucial, and they can really stop your project as well. Is that similar in Australia, or how is the structure there?
Yeah, the question of social license is really important, because you can get local communities objecting to, it might be a wind farm, it might be a solar farm. The big one at the moment is transmission infrastructure. And I think early engagement with the community and making them feel like they have a voice and they're part of the process is really important. I think what we've seen with some projects here is that the utilities end up having to pay quite a lot of money to the communities to just make them accept having, a transmission line running through their property, for example. And while I do agree that there should be some sort of compensation to the communities, I think if you're getting to that stage, it probably means that you haven't done the early works well enough. And something I saw recently in the news here is that some developers are proposing to build wind and solar generation in the far west of New South Wales. That's a state here. That's the state that Sydney's in. But what it means is it's really kind of in the middle of nowhere. So they were looking to get the transmission built to that area. But once it's done, because it's so remote, they anticipate that there wouldn't be any of these objections to the wind and solar, because there just aren't that many people living there. So I guess that's one advantage we have in Australia, that we've got so much space, we can build quite a lot.
Indeed, and so basically, even taking the power plant that much further from the actual population centers would kind of outweigh the losses of transmission, etc. So that's an interesting point as well.
It is, and transmission isn't cheap at all. I think transmission costs are going up, and there's, as we said, there's the whole social license question. But it sounds like they consider that was the easier pathway than trying to build closer to population centers.
Yeah, and I guess you have different objections. For example, I just came back from a conference here in Brussels on Tuesday, and the biggest takeaway that I learned is we had a lady there from the International Energy Agency, and she had some really good data on how much we installed across Europe, and that last year was something like 85 gigawatts. But the most important piece of data was that we have 400 gigawatts. Again, 400 gigawatts stuck in the queue. So basically, only if we cleared that, we would reach and exceed our energy targets by 2030. So, and I think that's one of the biggest and most underestimated issues, perhaps across the globe as well, that the whole curtailment and the grid connection queues are probably the biggest unmet need, right? And how does that work in Australia? Can you give us an insight into that?
Yeah, it's really interesting, actually, because I think the fact that the pipeline is that big shows that there's no sort of lack of investor interest. So the economics still stack up. But yeah, the grid connection is absolutely a bottleneck here as well. To the extent that we're looking at things like virtual transmission, using batteries either end of a transmission line to allow the transmission line to run at high capacity, and other. There are other sort of solutions to enhance the network without actually building more poles and wires, and those sorts of things are looking like some pretty interesting solutions as well. But I mean, you can't get away from the fact that at some point you will need to build more transmission. We've got a number of key projects here in Australia that need to get built to unlock what we're calling renewable energy zones, which are areas that have been identified by the market operator here as good areas to build wind and solar resources. And so we need the transmission links to those areas to open them up, basically. But it just takes a long time.
again, a lot more permitting, right? An average solar project you can bring to life in 18 months. When it comes to nuclear, 7 to 10 years, and then everything else. I guess the grid and new power lines would be somewhere in that bucket, right? The 7 to 10 years. So it's like quite far ahead of planning and investment as well. And I guess it begs the question to take this to the battery side, right? So you guys have actually built some massive battery sites as well. I've seen the Tesla Megapacks, etc. Of course, you have infinite land, but what is the approach in Australia, or what is Australia doing better than the rest of the world?
Yeah, Australia is installing a lot of batteries. I think the first big battery we had here was the Hornsdale Power Reserve. I think it was 2017 it was installed. That was the world's biggest battery at the time. It was just over 100 megawatt hours. We've come a long way since then. So we're now installing batteries of the order of sort of gigawatt hours. There's plans for ones that are multiple gigawatt hours. And I think if you look at the amount of battery storage that we're installing relative to the size of our grid, Australia is actually going faster than any other country. I think Chile was second. And I think, you've got to look at the reasons for this. As we talked about how much rooftop solar we've got in Australia. It's more than 4 million households. That's like 1 in 3 households in the country. And in the state of South Australia, it's every second household. So half the households in South Australia have rooftop solar. And of course, the effect of that is to flood the grid with a lot of excess generation in the middle of the day. And there's all sorts of problems that causes, which we can discuss more if you like. But one of the quick solutions for that is installing a lot of battery storage, because the batteries will charge in the middle of the day and they'll start to soak that up, and they can discharge it later in the day and help to meet sort of evening peak demand.
And that's also interesting, that the fall of the battery costs, right? So we've seen like the modules, we expected them not to fall this fast, especially last year, but they still did. And the batteries are following a similar pattern as well. And as new technologies also come online, like I anticipate the cost to fall even further, which makes it the flywheel, go a little bit faster still, that it's going to be more affordable for everybody to install, both on the residential and the utility scale side of things. And that's the key and important message, that the piece of data I have from Europe is that on a large scale, utility scale side, or power plant, you can actually get to a cost of around 6 euro cents of production price, and that's solar plus batteries already included. So around only solar, it would be around 3 cents, but this is a number from Germany, so that's already quite low. But if you can drive that even further, that's going to be even easier to convince the people who are not really into this, right?
Exactly. I think a few things to unpack there. But I mean, the initial batteries we had here had very short durations, and part of that was because of the cost. So they might have had a duration of only an hour or even less than an hour. And their role was really to just inject power into the grid at certain times to really support the grid, things like frequency response and so on. And then as prices have fallen, we've been able to have longer and longer duration batteries. They've become more economically sound. And so we're seeing batteries here, I think 4 hours is probably the default now. But we're also seeing 8 hours, 10 hours, 11, 12-hour batteries coming as well. And so that, at that stage, you're really starting to look at being able to charge up during the day and then run almost the entire night. It's starting to get into that world of round-the-clock solar. I think what's interesting as well is how much we've seen consumer batteries take off. It started with grid batteries, and now we're seeing a big wave of consumer batteries as well.
That's an interesting point as well, that, flexibility is something that keeps coming back at almost every discussion I have. I think there are multiple components to that flexibility, right? So we have, for example, here in Europe, every year you are seeing more and more negative hours, more and more curtailment. And okay, we actually installed some meaningful amount of BESS already that helps shave the peaks a little bit. But at the same time, the that flexibility needs to work across the board. So we should think about it as not just flexibility in a sense of being able to provide the energy when it's needed, but also provide the energy at the right price, right? Because you as an investor obviously are looking for some returns. You're looking at your IRR, and that is the most important use case or formulation that we need to find a solution to, and that should work at least on the midterm, right? Because everything is changing every year. But how is the approach to that in Australia? What are the kind of, perhaps tools or components of helping, guide this system and figuring out when to charge, when to discharge, and when to sell at the right price?
Yeah, at the moment, the potential for arbitrage for batteries is really, really high, because with all that rooftop solar, we're getting to the stage where we have very low demand, very low grid demand, I should say, in the middle of the day. And, the result of that is that prices can often go negative. And so a lot of these batteries will be able to charge up in the middle of the day for very little cost, or even they might be paid to charge up. And then, evening peak prices are always going to be higher. So there's a good arbitrage opportunity there for the grid scale batteries. I think what's interesting is that as we add more and more batteries, more and more are going to be charging up in the middle of the day. And so prices in theory won't be negative forever, because we're adding demand. And so that arbitrage opportunity actually shrinks. So the batteries are kind of eating their own lunch. So it'll be interesting to see how that progresses. But I think, what you were mentioning about the flexibility and orchestration and so on, are you talking more about on the residential side or at the grid scale?
The grid scale, because that's at least here in Europe, that's still much more generation, right? And that's something that if it's solved, then I think 80% of the problem is solved as well.
Yeah, I think we're heading towards a system where we've got millions of rooftop solar systems, hundreds of thousands of batteries. We've got electric vehicles and other flexible loads as well. And you just can't manage all those things manually. And that's where we need software to start orchestrating these and automating them, whether it's things like battery dispatch. So I think most of the grid scale batteries use a sort of auto bidder software to help them decide how to charge and discharge at the optimal times. We're talking about grid balancing as well, maintaining reliability and so on. And you increasingly end up with systems where thousands of distributed devices can sort of respond collectively to market conditions or grid conditions.
That's something that keeps coming back as well, that more and more devices and more components of the system. But again, we need a more holistic and more high-level system-wide thinking of how all of these components will work together, right? Because if we have a battery from one manufacturer, if I have my modules from another, I have my inverters from a third one, it's going to be difficult to establish the connection and make sense of the whole data, right? And that's not really an easy thing. And I guess on the residential side, nobody's going to write their own software. On the utility scale side, again, unlikely as well. But there you have a little bit more incentive to kind of figure this out, because a 1% drop in your yield, can cost you millions per year or tens of millions in production losses. So it's a bit of a two sides of the same coin, but really different needs, right?
Yeah, I think so. There is a lack of standardization here, and for any of these software companies trying to build the orchestration software and remotely controlled devices, a big part of what they have to develop is the integration to all the different manufacturers' devices. I think in some cases it can be easy. You could use a sort of aggregator, so you can integrate to one aggregator that will then have the integration to all the different devices. But there's a lot of work in just building out integration. It's far from standard at the moment.
Yeah, for sure. And I mean, the only kind of interesting use case I've seen so far is, Tesla was basically showing off this use case of the modular mega packs, where you have basically 4 containers shipped to site, and basically everything is Tesla from the hardware to software. So even the connection between the 4 containers and the software is from them. So then this is the only way. If you go more vertically integrated, which I guess in the battery space, not many companies can do besides Tesla and the Chinese manufacturers, right? It's going to be a tricky situation in a few years.
Yeah, it's a very diverse market. I think you're right, where Tesla does have a bit of an advantage there, being able to offer like the full stack and the software that goes with it as well. I imagine there will have to be some sort of consolidation or adoption of standards for people to be able to control these devices. But at the moment, it's quite fragmented.
Yeah, for sure. And on the fragmentation side, maybe you can dig a little bit deeper into different geographies, let's say compared to Australia, of what did you see in your professional career in terms of approaches to solar and BESS development? So if you look at, let's start with the US. So how does the US differ in terms of mentality and market dynamics compared to Australia?
Wow, that's a big question. Let's not delve into politics too much, but the US as a country is obviously a large country like Australia. But I feel like they have got more grid scale solar, even though they have a lot of potential for rooftop solar. They haven't reached the same sort of levels that we have in Australia. So they've got a lot of grid scale solar. And then you've got markets such as Texas and California, which are really sort of pushing the boundaries more than other parts of the country. So California gave birth to the famous duck curve, and they've also been installing a lot of battery storage. Texas built the grid infrastructure, and a lot of wind then came to the state. So it's been doing really well with wind. And now they are also installing a lot of batteries. I think what's interesting for me is that different markets sort of approach it different ways. And there's various reasons for that. Northern Europe probably has more wind. Southern Europe is more solar oriented, for example. But when you get to high penetrations of the variable renewable energy, then I think there's a bit of a convergence on the different sort of operational challenges that you're going to have, regardless of the geography. So you're going to experience variability. You're going to have a need for storage to kind of smooth that variability out. You're going to have a need for flexibility. Like, I think the demand side is a massive untapped resource, which we can talk about a little bit more if you like. And with that flexibility, you're then going to need the orchestration to make the most of it, to get the most out of it. And so, I think it's interesting how markets can start off in different places, but if they're all heading towards high variable renewable energy, they're going to experience the same challenges.
Yeah, for sure. And maybe let's discuss this demand side topic, because that's quite interesting and quite juicy. So you mentioned dynamic pricing, tariffs, orchestrations. How does that play out in real life?
Well, if you look at where we've come from in Australia, we've got this huge amount of rooftop solar, and you think of a typical house, it generates a lot more electricity than it needs to consume, especially in the middle of the day. So that floods the grid in the middle of the day. And so the question becomes, with huge amounts of low-cost solar, how can we encourage more consumption during those times? And as I said, I feel like demand-side flexibility is a really big, untapped resource. I think it's easy to understand that if we can shift a little bit of demand, that can often be cheaper and faster than building additional generation or even having to build additional network infrastructure. So it's undoubtedly valuable. And then there's different levers that we have. So one of them would be tariffs. If you look at tariffs, where they've come from, consumers didn't have digital meters, they had analog meters, probably a flat rate tariff, maybe, so people pay the same amount regardless of the time of day. Maybe it was peak and off peak, but in the old world, consumers rarely thought about timing. They wouldn't change their consumption habits based on thinking, oh, electricity is expensive now, I better turn something off. And I think if you look at where we're going now, we have digital meters, we have home energy monitoring devices. So you can just look at your phone and see how much electricity you're using at any time. You can see how much it's costing you. And an example from here, we have so much cheap solar in the middle of the day, but there's now tariffs here that will give you 3 hours of free electricity. As much as you like, it's free for 3 hours. And you can imagine that's a really strong price signal. I can speak from my own experience of how that changes how you consume energy.
For sure. And yeah, I mean, if we dig into a typical consumer of how the energy consumption has shifted, and of course we are expecting more and more electrification of everything, right, including from production to domestic consumption as well. That's going to still push our demand for energy higher. The question is, how do we consume it smarter?
Yeah, exactly. I think if you look at the traditional system, we have tended to match supply to meet demand. And so, the way the market's operated, we would look at what demand is at the moment, what it's expected to be in the next half hour or so. And then, we spin up enough generation to make sure we can meet that demand. And what we're increasingly looking at now is how can we shift demand to match supply? And there's various flexible loads that we can play with. Things like electric vehicle charging, that's a great one, because an EV is basically a battery on wheels, but it's also a large, flexible electrical load, just sitting in people's garages. And so, my personal experience, I had some time on one of these 3-hour free tariffs. And for me, I would do everything I could during those 3 hours. You can schedule the car to charge if it's at home. It was in winter that I was on it, and so I was scheduling the heating. The heating would go really hard for 3 hours, probably heat the house up a little bit more than it needed to, and then then it can just sort of coast the rest of the day, so we can get away without needing heating for the rest of the day. And there are other flexible loads as well. Some people have pool pumps. It doesn't really matter when they run, so that's a good one. Hot water is another one. Electrical hot water. You can have that run in the middle of the day, and then the water's going to still be warm come the evening. And so I think it's really interesting how these tariffs can change consumer behavior. But I think we can't really get away from automation, because how many consumers want to spend their time thinking about energy?
Nobody. Or one in 100 maybe. Yeah. If you really find pleasure in trying to plugging this system together, yes, you are the one. But I think the others, they are just basically want to forget about it and basically try to make the most or out of their consumption patterns or behavior. But again, incentives drive behavior, right? So that's the most important part, to build the right incentives to drive the right type of behavior for people, that be build reduction or some for people who care about the environment. Yes, that's the added value as well. But I think again, finances solve everything.
They do. I think obviously not everyone wants to become an energy trader or optimizer. I think the average person probably just wants lower bills, greater convenience. And that is, again, where the automation comes in. Because another example, the 3 free hours is quite easy to remember, but there's also tariffs here where you're exposed to the wholesale price of energy. We call them dynamic tariffs. And so the price you pay varies every 5 minutes. And of course, even the most enthusiastic energy nerd isn't going to be looking at their phone every 5 minutes and turning things on and off to try and, you just can't keep up with that. And so that's where software again becomes really useful, especially if you have a home battery, because now it's looking at, well, can I charge the battery off rooftop solar? Can I charge a battery because wholesale price is really cheap? And then let's look at the forecast. What is there going to be a price spike later when I can discharge the battery and sell energy and make a profit for this consumer? And let's also factor in the consumer's typical consumption patterns. I know they're probably going to run the dishwasher in the evening. I need to allow a little bit of energy for that and maybe for cooking, and so on. And I think, the software is getting quite advanced now that it can learn what your consumption habits are. It can forecast what energy prices are going to be, and it can really optimize the battery for you so that you get a return on the investment. You're not just optimizing your own rooftop solar generation, but you're also sort of making a profit from the battery as well.
True, and that's the most optimal use case. But you mentioned the keyword that really spiked my interest. So you mentioned price spike. So it really forces me to steer into this direction of the whole Iran war situation and the energy crisis. How has that played out on the Australian side? Because here in Europe, this is basically the top of the news, top of the discussion, both political and industry level as well. And there's no quick solution to that. But on the flip side, it actually gave us, at least in Europe, even more motivation of really being able to detach from gas, or as much detachment as possible. How has this played out in Australia?
Yeah, we've definitely been impacted here. I think Australia is the world's largest importer of diesel. If you look at diesel consumption per capita, we are by far the world's largest consumer per capita. We have had queues at petrol stations. We've had some rural petrol stations apparently running out of petrol. Obviously, anyone that owns an electric vehicle is feeling quite content with their purchase decision now. And what that's meant is, if there's any sort of silver lining to this war, it's that there has been a massive shift in demand for electric vehicles and away from fossil fuels. And I mean, and that's not just at one level, that's at the consumer level where people are going out to buy electric vehicles, but also at the government level, looking at what policy changes are needed to really reduce our dependence on imported fossil fuels, because it's clearly a massive vulnerability.
Of course, fuel is one part, right? So you need, this is the mobile part of the industry, but as when we look at fuel as an industrial input, as we mentioned at the beginning, it's quite tricky, because at least here in Europe, we are in a really weird place where PPA prices are falling, which means the investment into renewables are getting a little bit less attractive, but the energy prices are going up. So we are in this paradox of like, okay, how do we solve this? It's because if the money doesn't flow in, that's going to impact future project build out, but at the same time the energy prices keep rising.
Yeah, it is. And low, we can celebrate low price for solar and wind generation and so on, but those low prices, they get too low, then as you say, they stifle investment. I know here in Australia now, you wouldn't really get a standalone solar farm being built because there just isn't the return. With all that rooftop solar in the middle of the day, the grid scale solar farms are often being curtailed, and so they pretty much have to have on-site battery storage now, so that they can generate the solar, but then send it to the grid later when the grid actually needs it.
Yeah, so it drives back to the point of flexibility, right? And also we still live in a high interest rate environment as well, which makes the job a bit harder as well. Loads of capex that needs to go out of your pocket first of all before you start generating. And I'm working with a couple of companies on the transaction side as well, and there the data is clear. Investors are willing to pay for assets, even higher premiums, even for a lower return, as long as those assets do have a reasonable track record, and those assets are in the later stage with BESS, solar, wind. So the hybrid project is becoming more of the standard. So it's exactly what you mentioned as well.
Yeah, I can understand that. It's interesting times, isn't it? There's a lot of challenges going on, and I think the only positive thing really is that, as you say, we are seeing a surge in the build out of renewable energy. I mean, I saw a statistic just a few weeks ago that in March, exports of solar panels as well as cells and wafers from China, they doubled, in 1 month. And I mean, that's just crazy. I think it's crazy because to think that the supply chain can flex that quickly, but also it's pretty amazing that the world would react so suddenly. You think that to make an investment decision and to decide to build out a solar farm, for example, would take quite a long time, but it feels like this crisis happened, and then just like that, flicking a switch, people are able to say, right, we need to get some solar panels in, let's go.
That's a huge thing as well. And, especially on the supply chain side, to be able to react so fast, okay, in terms of China, they definitely have some good indicators of what may happen, plus a little bit of surplus as well. But ultimately, we will really need to look into our supply chains as well across the globe, right? And try to vertically integrate or reshore some of those productions. And that's a huge topic here in Europe. We are discussing about that for a long, long time. But on the other hand, it's going to be difficult to make it financially viable, right? The price we can produce at here in Europe is never going to be as cheap as in China. And also at this point in time, we also don't have the technology to produce those panels at scale. So it's also a bit of a tricky situation.
It is. I think it's a really valid question on whether Europe, it's clear that America wants to try and do it itself, and how successful it will be remains to be seen. But, putting a 100% tariff or basically banning Chinese imports is going to reduce consumer choice. So they might have to buy the American-made ones. But in Europe, like you say, you're starting from a long way behind where China already is. So China has that huge industrial machine. It's already scaled. It's got the efficiencies and the product sort of development and advances. So how much of a price is a fair price to pay so that you have that supply chain certainty? And I'm not sure. As a consumer, would a consumer really care? Would they just want the cheapest panel? I think they probably just want the cheapest one. It's more the politicians that feel like they need to have a degree of, energy security, I guess.
Yeah, and also it's also something that came up at the Solar Power Summit as well, that they kept mentioning energy security and cybersecurity side by side. So in other words, I think we will see a day quite soon where you will need to be mandated to use X amount of, modules, inverters, different hardware produced in countries where you can't just be switched off, right? Because eventually, if you look at this across the globe, 80% or maybe even a higher number of the hardware is coming from China. And okay, us here in Europe, we have a good relationship with them, but technically speaking, it's quite easy to turn the power off, and it's a real threat. We had a Russian cyber attack in Poland on some sites, so that's quite a real threat, and I think that's going to only intensify if the world continues down this path.
Yeah, it is interesting, isn't it? We traditionally think of stocks and flows, and countries for a long time have imported fossil fuels where once you've burnt it, you need to buy more, you need to import more. And so that's a very much a continuous ongoing dependency. Whereas we think if we buy solar panels, yes, there's a dependency up front, but once you've got them, you're kind of generating your own electricity. But then when you put that in the context of, I think it's the inverters that are the devices of concern, isn't it? If those inverters have monitoring devices in them, communication devices, they can just be switched off remotely, then that is it's a huge risk. I think, is Europe talking about a law where the inverters are going to have to be made in Europe? I think that's something I read recently.
It's hazy to my knowledge, but yeah, inverters, that's the only part where we are kind of okay, where we can produce in Europe a meaningful amount. But still, there are the other components. So it's also something that I think is going to be implemented quite soon. By soon, I mean like 1 to 3 years. It will have to be implemented. And I've seen a great panel discussion from I think the energy minister of Lithuania or Latvia. So they actually managed to disconnect from Russian gas in 10 years. So they saw what is happening. They saw the Russian forces across the border, and they just said, okay, no more. So they have created a plan and actually executed on that plan. So they import zero Russian gas at the moment. And that's quite impressive.
It is. Lessons for the rest of Europe, really, isn't it? Where it feels like the current crisis is almost a reminder that, we got a warning a few years ago and maybe didn't move as fast as they could have done. And now it's happening again.
I mean, usually we are quite slow to adapt, but now I hope this is going to put some wind in our sail and it's going to be executed on as well.
Yeah, I hope so too. It's difficult times, but times of great change, isn't it? I think something that Europe, maybe you can comment on this. Europe, especially Germany, seems to be one of the few countries that is still pursuing a hydrogen agenda. We had a lot of hydrogen hype in Australia in the last few years, but I feel like, and I don't just mean for mobility, not for hydrogen cars necessarily, but just for everything, for long-term energy storage and so on. I feel like we've kind of moved past that to a large extent in Australia. But as I understand it, Germany still has a hydrogen plan and they want to import hydrogen from other countries. And is that for energy storage purposes or?
Mostly, well, to my knowledge and across Europe, people are viewing this as the last piece of the puzzle. So if you get to like 98% renewables, then maybe hydrogen is the last step to get to 100%. So, once you can store that excess solar long-term in a different way, shape or form that you can mobilize when needed, apparently that is the last use case. But I was actually chatting about this with a good friend of mine, Dr. Marek Kubik, and he's an expert on battery storage, and he said, yeah, I mean the hydrogen part could be the solution, but it's still a long
way
from where it needs to be, right?
Yeah, it sounds like when you look at the losses in the end-to-end process, you generate renewable energy, assuming it's green hydrogen. Then we have the electrolyzer to create the hydrogen. And then if we're transporting it, then, are we converting it to a liquid? Are we going to lose some hydrogen in the ship that transports it? And then, we're going to burn it to generate electricity at the other end. I mean, yeah, I guess long-term energy storage is just a whole area that we haven't really solved yet, right? There's a few different chemistry batteries that are out there. There's things like compressed air, liquid air storage, but I feel like we haven't really cracked it. And that probably doesn't matter yet. We have time. As you said, it's the last few percent. If we get to a grid that's 95% decarbonized by 2030, 2035, we're doing pretty well. And then we can worry about the last few bits.
For sure. I think this is really the last question to be solved. But there are some interesting technologies. I've spoken to a company called Polar Night Energy from Finland, and they do storage in sand. And that's a really cool tech, that you build a silo, you fill it with sand, and then that also partially solves the question of longer duration storage. So they can store it a couple of weeks based on that description. So that's interesting. And apparently the energy density and the price is getting comparable to CATL. So that's an interesting use case that we should focus on a bit more, I think.
Yeah, I've heard of them. I think Caldera is another one in England. This is thermal energy storage, isn't it? So I think they're talking about giving you useful heat out the other side, but not necessarily converting that back into electricity, but actually using it as heat.
The latest version, you can do both. So that's a pilot, but that's going to be the holy grail. But for them, the easiest use case is industrial heat to be tackled and industrial processes where you still have this steam engines, running the process, but still a really good starting point, I think.
No, it is interesting. And I think we'll see more and more things like that. It's funny because I think they use sand, don't they? I think a long time ago in England, well before my time, it was common to, when you had a wood burning fire in your living room, and so that would be what was keeping the house warm. Maybe it was burning coal, and then you would put a brick in front of the fire, and just a clay brick, and the brick would absorb heat from the fire, and then when you went to bed at night, you would take the brick with you into the bedroom, and of course the brick slowly discharges or sends the heat back out into the room and kind of keeps your bedroom warm overnight. So it's a very early form of thermal storage, but quite effective.
Yeah, for sure. I mean, most of these dynamics are just rooted in the laws of physics, right? And that's what we need to focus on for first principle thinking, right?
It is, and I guess coming back to what other stuff we've been talking about, that's why the challenges we're seeing in Australia and the solutions we're coming up with are probably going to be very similar to the ones that play out in the rest of the world as well. Things like batteries, flexibility, and so on.
And Gavin, you mentioned the past already, but how did you actually end up in solar?
Yeah, it's more just a passion, I would say. If you look at my career, I have been working in the energy and utilities industry the whole time. But for me, it's mostly been on the software side for utilities. So customer information systems, billing systems, and increasingly now the software that can orchestrate large numbers of, distributed energy resources. But the actual sort of energy transition is obviously a lot broader than just utilities software. It's transmission, it's building out generation, flexible demand and stuff like that. So yeah, for me, it's just really a personal passion. It's something I like explaining things to people about. I like communicating about it. I feel like there's an awful lot of misinformation out there. And I think it's really helpful if people can come up with some clear, easy to understand, very much fact and data-based analyses to kind of explain things to people, and things like why a solar panel will generate a lot more energy in its lifetime than it costs to make the solar panel. Why putting in a battery is going to be beneficial, and it's not just going to last 5 or 10 years, and so on. Because there's always a lot of people, invested interests, trying to slow down the transition, but a lot of their arguments don't make sense. And so I think it helps to have some really clear inputs to help people understand, why we're doing this and why it makes sense.
And speaking of the data side of things, you're certainly doing a great job at it. I actually found you on LinkedIn, and I've been following you for a long time. And I think, the content you put out there, it's A, really informative, and B, very easy to digest. So that's two of the components that make great content and that reaches the audience, and it's actually absorbed by the audience as well.
Thank you. Yes, it is something I enjoy doing. With content on LinkedIn, it's a balance between how to come up with content that's going to reach a wide number of people, but also content that's going to satisfy the more detailed oriented and technical people in the audience. It's sort of which end of your audience are you optimizing for? For example, if I post something about Australia, then the European audience might be just interested in the headline numbers. They'll be like, oh, wow, Australia's installing so many batteries at the moment, or something like that. But obviously the people in Australia that are seeing that content, they're going to be at the next level of detail, and they might want to engage on the policy, on why things aren't as good as they could be, and so on. So it's always a balancing act, but it is something I enjoy doing.
You mentioned that you are contemplating your next move in terms of your professional career. Is there anything that you can hint on, or any direction that that's kind of shaping out to be a plan already?
Yeah, look, I'm having some interesting conversations at the moment. I think I will be staying in energy and utilities. Probably looking at maybe getting more into advisory, so that my work can be more closely aligned to the sorts of things that, for example, I post about on LinkedIn, and, helping companies navigate the energy transition, working out what is the impact for you on this market rule change, for example, helping software companies navigate the changing market conditions and things like that. So I don't think I'll be going very far, but it's certainly a very interesting space at the moment.
Yeah, I mean, there are very, very few people I met who worked in renewables and left. So I think that's definitely a bug. If caught, it will never let you go.
Yeah, I think you're right. It's like an electric car, isn't it? How many people drive an electric car and then say, well, I'm never going back to petrol now?
Gavin, we actually talked a lot about batteries, but you have a great example about the Australian home battery scheme. So maybe let's discuss a little bit more about that.
Yeah, sure. So, we talked about grid scale batteries, where Australia's installing a lot and probably at a faster rate than any other country relative to the size of its grid. But also, we now have a federal scheme, a federal government subsidy called the Cheaper Home Batteries Program. And it started in July last year, and it subsidizes roughly a third of the cost of a home battery. And the uptake has just been vastly in excess of what was expected. So it's been going for 10 months now, and we've seen 380,000 batteries get installed, which is, in 10 months, that's more than 1,000 per calendar day, let alone per working day. And that adds up to nearly 11 gigawatt hours of storage. To put that in context, that first big battery that was installed in Australia, nearly 10 years ago, well, the amount of storage Australian households have installed in those 10 months, it's 70 times as much storage as that first grid scale battery we had. So it's a really staggering amount of storage. And I think it's already having an impact. We are seeing an increase in midday demand, and those home batteries are some of them will be feeding back into the grid as well to help meet the evening peak. But even if they're not, it's meeting that household's demand in the evening peak. And so it is tending to reduce peak demand and hence prices. So it's been a hugely successful program.
Wow, that's a huge amount. 11 gigawatts. I think to roll that out, it would have probably taken the same amount of time to do 11 times 1 gigawatt as well. So it's a huge achievement.
Yeah, I think it is. It's fast. It's also distributed, and this is just the first 10 months, and the scheme's going to run for years. So just imagine what we're going to look like by 2030. I guess we didn't talk too much about the consequences of all that rooftop solar. I suspect these are consequences that other markets have seen as well. But I said how households generate far more electricity than they need to consume, especially in the middle of the day. And so all that excess electricity is just exported to the grid. It doesn't have to be dispatched. It doesn't go through any sort of competitive bid process. It's just sent to the grid, and the grid has to take it. And so you end up with very low grid demand. And that means we can get negative prices. And, some people think negative prices are a failure of the market, but I think it's really just a market signal showing that at the moment we've got, more generation than the system needs right now. Those negative prices come with problems for some large-scale generation. It leads to economic curtailment. So wind and solar farms might have to turn off when prices are negative. But this is in some ways that the batteries is an example of how the system's now adapting to that.
Yeah, and that's a really important component as well. And I think the more people understand not just their own domestic consumption, but the system at large, the more stable the system will become, and ultimately everybody will benefit, right?
Yeah, exactly. I feel like it is an energy transition. It's not going to be done overnight, and so this is a natural kind of consequence. I think rooftop solar paved the way to a market that incentivizes batteries in a way. It created the opportunity for batteries to be economically sound. And also, the negative prices mean it's great for batteries. They can be paid to charge up in the middle of the day, but at some point, those prices won't be negative anymore. And like we said, the spread, the arbitrage opportunity gets reduced. But that's probably a good thing in many ways. It leads to less volatility and a more stable system.
True. And what we are seeing here as well, that the flexibility aspect always also translates into not just the flexible discharge, but also flexible production as well. So Europe traditionally, until 2024, you really saw a small percentage of projects built with trackers. But now, especially in the south, it's becoming more the norm. And even in Germany, due to the flexibility and the negative pricing, we see more and more trackers being installed. So you can respond a little bit more flexibly to that demand as well. So that's also another part of the system.
Yeah, it is. I I think that's one of the broader lessons we're seeing in Australia as well, that the high renewable systems are increasingly rewarding flexibility and responsiveness and orchestration. They're going to be the useful tools going forward.
And on that note, Gavin, I think we are getting to the end of our time. If you could give a shout out to the audience, who would you like to speak to and how should they reach you?
Yeah, look, I'm pretty active on LinkedIn, as we were just saying. That is probably the best way to get in touch with me. So you can look me up there. And yeah, I'm always happy to hear from people. I get quite a few messages and things. I try to respond to as many of them as I can. But yeah, always happy to connect with new people.
Awesome. So we will link to your LinkedIn profile in the show notes below. And on that note, Gavin, thank you very much for sharing your knowledge about Australia and the whole world. And let's do this again soon.
Thanks, Peter. Sounds great.